Hey, Didi. I think that might have been an awkward start, but anyway. So let's go through what he's talking about in your lecture notes here. I do agree they are presented in kind of a strange way, but I think the idea is that he's just trying to maybe, or they, she, I don't know, just trying to explain, review quadratics, right? So when you're solving quadratics, there's a few different things that can happen if you're starting from standard form. So remember, standard form is when you have ax squared plus bx plus c, some a, b, and c, like that. So there's two things you can do. You can factor, or you can use the quadratic formula. So the disadvantage as immediately going and trying to factor right away is that it can be kind of complicated. And what happens if you try and try and try and try and it's not factorable? That can be really annoying. So for example, 2x squared minus 6x minus 20. Sorry, I don't have my thing with me, but anyway, handwriting's a little messy. So here we could say, okay, 2, and then it's x squared minus 3x minus 10 equals 0. And then, what if this was really hard to factor and you couldn't find your answers and it would be really challenging? So what he's saying here, I think you said it was a he, was that before you even start trying to solve a quadratic equation, what we're going to do is look at what's called the discriminant. And yeah, it sounds like the word discriminate because it helps you determine what type of a quadratic it is. So you're basically discriminating against quadratics. And so remember, the whole quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's your quadratic formula. And the discriminant is the part underneath the square root. And that is what determines what kind of answers your quadratic is going to have. So, for example, if you have a 0 underneath the square root, you're going to have one answer. If you have a negative number underneath, let's go through his examples anyway. So, his example said if it's bigger than 0, then there's 2 real solutions. Makes sense. If you have 0, then there's only one solution. And then if you have less than 0, then there's no real solutions, which means another way to say no real solutions, instead of saying, we say the word imaginary, right? Imaginary numbers, or you can call it a complex solution. So this is just a lot of vocab that maybe you're not familiar with, but I know you got this quadratic knowledge deep in your brain. I know you do. All right. So what they're saying here is that, okay, so if you have a discriminant that is positive, then basically, okay, then just plug everything in and find the answer. If you have a discriminant that is 0, then everything underneath the square root disappears and your quadratic formula just becomes negative b over 2a. So it's like a simplified quadratic formula if you know your discriminant is 0. And then finally, this next answer is doing the same thing. I know it seems kind of annoying. It's saying you can find the complex answer by just, plugging everything in, plug in your B's and your A's and your C's and simplify it to find your complex answers. Or you could plug everything in into these two formulas here, and that will give you your answers that are partially imaginary, partially real. That's why we call them complex. So they're so difficult to understand because they're complex. Okay, so then it looks like he goes back and he plugs in the value that he found for the discriminant. So remember, the discriminant is just all this junk in the trunk under here, this b squared minus 4ac. So in this case, he found that that was 196. So he's saying, let's see, what was b again? So 6 plus or minus the square root of 196 all over 2 times a, which is 2, right? And so we could separate that into 2 separate x's and say, okay, one of them is positive, one of them is negative. So there's a -1, and then there's also a +1 over 2 times 2 is 4. But I'll just write it as 2 times 2. So that's what he's doing here, is he's saying, okay, one of the answers is when we have a plus, and one of the answers is when we have a negative. I would agree that this is making things more complicated. And he's using a lot of vocab, and he's breaking it down. I think it's just a difference of how you learned the material. So here he does the math, right? And he finds that his 2 x's are 5 and -2. So for the examples that he has here, you would just do the same thing, taking a different path depending on what your discriminant is. So let's take a look at this first one. We would have, I mean, to me, I think he's doing it in a very complicated way, because when I look at this, I'm like, okay, I could just factor this, right? I could just say this is the same as x minus 5, x plus 2, and then my x value would be 5, and my x value would be -2. So why would I use the quadratic formula if I didn't have to? But, sometimes you just got to do it the way somebody else wants you to look at it. So there's that. Let's look at it his way. We're going to find the discriminant first, which is actually a good strategy. I approve of that message. So discriminant is equal to b squared minus 4 times a times c. And so the discriminant is 9 minus or plus 40, which is 49, which is nice because it's going to be under the square root. Square root of 49 is 7, so you don't have to deal with any stupid simplifying square roots or finding decimals or anything like that. So that's going to be good. So looking back at our options for what could happen, case 1, b squared minus 4ac is greater than 0. And that's the case that he gave you here. And so what you're going to do is you're just going to kind of continue on with using the quadratic formula. Now, to explain the way he did it, he broke down the equation into 2 parts rather than doing the one quadratic function in 2 different ways. So he's saying, okay, the first x is equal to negative b, which is 9, so negative, or 3, so negative, -3, plus or minus the square root of the determinant, right, discriminant, which we put there. So we could do the square root of 49 all over 2 times a, which in this case is 1. And then the second x is -3 minus the square root of 49 all over 2 times 1. And I'm sure you understand how to do this, but we should get the same answers that we got over here, right? It's just 2 different strategies. And so this one, when we substitute, this one I think is going to be the -2, and this one is going to be the +5, I believe. So that would be what he's talking about there. So I encourage you to try the second one, and then look at which case it is. Is it negative discriminant, 0 discriminant, positive discriminant, and then follow along with his method just to learn his method. But yeah, again, it's just another strategy. He's adding more notation, more vocabulary, more formulas. I don't know that it's that necessary, but it's good to know where your professor is coming from and like how he knows how to do it. So then when he's explaining it later, maybe it'll make more sense. I'm happy to come back and do that last question with you if you need me to.